Hello, this is Chapter 5, Probability, Section 1, Lesson 5.1. I apologize for my voice. I'm not feeling well, so these Chapter 5 videos are forever going to be me being sick. So, anyway, let's move on. So, this chapter is about probability, and this lesson is on randomness, probability, and simulation. The idea of probability is that a random process generates outcomes that are determined purely by chance. So this is important, that it's just chance that creates the outcomes. And a trial is one repetition of a random process. So one trial is one repetition. They are equivalent in the words that you could interchangeably use. And the probability of any outcome is between 0 and 1. So that represents 0% chance of happening, and the 1 represents 100% chance of happening. Also think in terms of, the decimal version of what a percent can be represented as, okay? And so in class we did an activity, which on these video lessons obviously we don't do, but we're just going to go over this particular thing here. My brain is not working properly. I'm sorry, I'm not feeling well. But so this is the number of tosses, coin tosses. So if you only tossed a coin a couple of times, you're either going to get heads or tails. And if the probability of getting heads, if you're counting that probability of heads, and if the first toss is a head, then it's 100% chance you got heads. We know that the theoretical probability of getting heads is not 100, not 1 or 100%. It's 0.5 or 50%. However, in the short run, with few tosses, the outcomes are very erratic. So you'll see that the probability will go all the way from being 1 to 0.5 to 0.65. This depends on how many tosses you are doing. The more tosses you are doing, the more it levels out over time. So as time goes on, with many, many tosses, the proportion of heads settles on 0.5. This is called the law of large numbers. It says that the more and more repetitions, the more and more trials are done, that the outcomes approach its theoretical probability, its expected probability. Like in this case, probability of heads will be closer and closer to 0.5. But in the beginning, it's all over the place. And if we zoom in on this little area, this is what that looks like. And so if my coin toss activity resulted in like if we did an activity here with the coin toss, and it resulted in heads, 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 what do you think the next one will be? Is still a 50% chance that it's going to be heads or tails. So many people think, oh, well, if we got a heads, 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 there probably is going to be a tails, more likelihood that a tails will happen. That's not true. As much as we think, yeah, sure, it could be tails, but the likelihood of it being heads or tails is still 50% chance. So 0.5 is the probability. What people are erroneously believing in is law of averages. This is a misguided belief. It doesn't work out that way. When you can't be due for something, and I hear this a lot of times from people that don't have mathematical backgrounds. So just know that the probability of heads versus tails is still 50% here. The probability the idea of probability is that randomness is predictable, but in the long run, in the short run, it's not so predictable. But in the long run, it is predictable. Just to make sure you understood this particular concepts up to here, do the check your understanding problems. I would pause your video here. And these are based on all the stuff that was just discussed above. So check your work once you attempt the problems. So simulation is what we're going to start with. And the activity that we had done in class was a simulation, particularly with a die, rolling a die, because it was 1 in 6 chance of winning. But simulation is the imitation of chance behavior, and it's based on a model that accurately reflects the situation. And there's 4 parts to a simulation. You're going to state, you're going to plan it, you're going to do it, and you're going to conclude. And it's best to explain with the actual problem. So I'm going to go straight into that. We did these in class together as well. At a local high school, 95 students have permission to park on campus. Each month, the student council holds a golden ticket parking lottery at the school assembly. The 2 lucky winners are given reserved parking spots next to the school's main entrance. Last month, the winning tickets were drawn by a student council member from the AP Stats class, and both of the golden ticket members, not members of the same class, some people thought the lottery had been rigged. There are 28 students in the AP Stats class, so they're saying design and carry out a simulation to see if it's plausible as in possible, that the lottery was carried out fairly. And they're using line 139 in the random digits table. If that was not specified, you would pick any line yourself, but they specified it in this question, so we should all get the same answer. So the stating part is you're going to state what you're trying to figure out. You're trying to figure out what's the probability that a fair lottery would result in 2 winners from AP Stats class. That's the question at hand. And planning it. So this part is the most difficult part, to come up with a plan for it. So if we're using the random digits table, we need to number the students. And you need to come up with a clever way of numbering the students. Not so clever that it's so complicated, but just easy, the easiest possible way. And there are 29 AP Stats students and 95 total students. So if you look at the 95 and the 28, and these 28 from the 95, so these 28 students are within the 95. So it would make sense to number the AP Stats students 1 to 28, and then the rest, 29 and to 95, would be all the other students that are not AP Stats. But remember, we're using a table, the random digits table, so they have to be the same number of digits. And since 95 is 2 digits, we're going to use 2 digits to also represent the single digit numbers like 01, 02, 03, etc. So that's why it's important to have that 0. And this is a concept we learned in a previous lesson, like chapter 4. So label the AP Stats students 01 to 28 and the remaining students 29 to 95. And with any table, we always have our label to select. We're going to select 2 digits at a time, starting on line 139, because that's what they stated. We're going to ignore, we have an ignore rule for this table. We are ignoring 00, anything that's past 95 to 99, and any repeats. And then we're going to stop after getting 2 distinct numbers. Keep track of how many months were both from AP Stats. So this whole process, stopping after getting 2 distinct numbers, represents 1 month to simulate a month of drawing 2 people for the golden ticket. And so if we look at line number 139, you'll see these digits. These digits appear on line 139 on your table. And these are like, I labeled it and I organized my information like this is month 1, month 2, 3, 4, 5, 6, etc. We did this until month 20 in class. So if you look at the first 2 digits, I'm literally carrying it out here. This is my do part. I'm carrying it out. I'm selecting 2 digits at a time. I'm ignoring 00, 96, 99, and any repeats. And I'm stopping after I get 2 distinct numbers. So I got 2 distinct numbers already. I stop. This is month 1. And I look. I'm not ignoring, because they're not in these. But neither one of them is AP Stats students. They're from the non-AP section of the students. And then I do this again. So this is month 1. 2 students were selected, not AP. Month 2 was 89 and 94, again within the range of what we can accept. Both are non-AP. Month 3, notice one of them is an AP student, 04 is, the other is not. And I keep doing this, 70, 84, not AP, not AP. On month 5, I end up with a situation where it's past, it's within here, they ignore. So 10, 98, I ignored the 98. Then that means I have to get another one. 43 was the next one. 10 is AP student, 43 is not. And I keep going. And the first time both of them are in AP happens in month 10. So on the 10th month, I got a 19 and a 12. Both are AP stats students. And I repeat this process. In 11, I had to ignore this, so I ended up with these two. Month 16, 2 AP kids. Month 17, I ended up with 0, 0. I had to ignore that, but regardless, they were non-AP students. And then month 8, both were AP students after I ignored the first 0, 0. And so in 20 trials, this is a repetition trial, 3, trial 4, trial 5. In 20 trials, 3 of them yielded both students being AP stats. And then the book does it more, 50 reps. It happens 5 times on this, continuing on the same path. So we are going to use these, probably this one, since the more repetitions, the better. And so the conclusion is that because 5 out of 50 is 10% of the repetitions yielded 2 winners from the AP Stats class, it seems plausible that the lottery was conducted fairly. You could also include saying, although unlikely, it still seems plausible that the lottery was conducted fairly. So this is basically pretending like we're doing the lottery, using another way to represent the chance process of what selecting 2 students from a group of 95 students, with the first 28 being a specific type of student, and and what that outcome could be. And it helps us calculate a probability using alternate methods than actually carrying out the lottery, hence the name simulation.